All right, so I'm just going to solve number 3 on the problem set 2 for Newton's laws. So in this problem, this is a friction one. So we have a coefficient of friction given. So it says the coefficient of friction between a 35 kilogram crate and the floor is 0.3. With how much horizontal force must you pull a rope if you want to accelerate the crate at 2 meters per second squared across the floor? This is a pretty standard problem. You basically have, some crate object here, and you are trying to pull it. It says horizontally with some sort of a rope here, and so we're trying to move it horizontally. There is friction on the floor. They tell us the coefficient is 0.30. They give us the mass of the crate as 35, and they give us the acceleration that we are desiring at 2 meters per second squared. So if I'm just going to try and do a free body diagram here, then, sorry, my dog, she's excited about something. So free body diagram, I'm going to draw the normal force upward here, call that F sub n. I'm going to draw the force of gravity here, which is our downward force. All right, and I drew those forces in blue because those are my y direction forces. Now in red, I'm going to draw the x direction forces. So I have the pull from the person on the rope. And so because it's a rope, I'm going to call this tension. And then on the left, there is a resistive force of friction that's trying to slow the crate down. All right. So that's where we're at with that. So how do I go about solving this? Well, you start with writing out your equations once you have your free body diagram. So we'll start in the x direction. I have a positive force in terms of tension, a negative force in terms of friction. So my equation I'm going to write out is Ft for the tension positive minus the force of friction, FFR, equals, and then this is mass times acceleration, but the acceleration I'm looking at is the horizontal acceleration, or AX. Okay. And then I'm going to also do the same thing for my y direction forces. So I'm looking at Fn and Fg. Okay, so I got Fn again is upwards going to be positive, downwards going to be negative. So I have Fn minus Fg equals ma, and this time I'm going to put ma sub y for my y direction velocity, or y direction acceleration, the up and down acceleration. Okay, so thinking about what you know in terms of what's given in the problem, we have the mass given. We know the horizontal acceleration we want, or ax, is 2. And ay is going to be 0 because it's going to stay on the floor. So I know that this term is going to go away because ay is 0. So I know the right-hand side of that equation is going to be 0. And then I know the equation for force of gravity. That's always the object's mass times g. So this is what I'm going to plug in for Fg there. All right, so if I have 0 and I have mg, then I can solve for force normal as being equal to the mass of the object. So this is going to be a negative mg. I add it over to the other side. So I get 35 times 9.8. And this gives me a normal force of 343 newtons. All right, so that doesn't help answer our question of the horizontal force. So we're ultimately looking for the force of tension here. This is our desired answer. But we now can use this 343 in this friction term here. So tension here minus the force of friction. The equation for friction that we plug in is mu times the normal force. So mu Fn, and that equals m AX. And m is 35, and AX is our 2 meters per second squared. All right. So mu is going to be plugged in as 0.3. 0.30 is our given coefficient of friction. And then the normal force, I'm actually going to plug in all from the right-hand side of the equation. That's going to go in here. So I'm going to do 0.3 times 343. So my force of tension will be minus 0.30 times 343 equals 70. 35 times 2. Multiply those together and add them across, and you get a tension force of 172.9 newtons. All right, and that is your horizontal force to accelerate it at 2 meters per second squared. All right, and that's all there is to it. So hopefully this helped, and you'll be able to solve the other 3 problems on this worksheet. All right, good luck.